Dilations, next day activity. You should be working ahead of me and then checking, but this is an explanation you can watch after doing the activity if you need to go through. Quadrilateral KRMY was created by dilating WTDH, so it was a shrink. But the ratio of side WT to segment KR is 5:3. And we need to use the word blank to fill in, and we also need to figure out some ratios at the bottom. So if it's 5:3, then the length from P to T is 5, and the length from P to R is 3. Which means that other part up there, length of segment TR, is 2. All right, filling in the blanks. Point P is the center of dilation. KRMY is the image, because that's what we get after the shrink. WTDH, that quadrilateral, is the pre-image, and our scale factor is 3 to 5, because we're getting smaller. So it's 3/5. This has got to be between 0 and 1. So let's look at this. Ratio of WH to KY. Well, we don't have any links, but we know the ratio is going to be the same for every pair of corresponding sides. So that's 5/3 or 5:3. Ratio of segment PR. So the length from P to R is 3. Length from R to T is 2. So that's 3 to 2. Problem number 2. We have points D, H, K, and T, and they're shown on the coordinate plane. Each point has been dilated using the origin as the center of dilation. Excellent. We need to complete the table and determine the scale factor. So it's going to be different for each pair of points. Let's start with D. So looking at D, that is at 9, -6, and D prime is at 3, -2. So new divided by original. We can do -2 divided by -6 or 3 divided by 9. Either way, we get 1/3. The dilation can be explained. Any point X, Y is going to go to 1/3 X and 1/3 Y. Let's look at H. H is located at 2, 1, and H prime is at 6, 3. So new divided by original is 3 divided by 1, or 3. So same kind of thing for the dilation. Any point X, Y is going to go to 3X, 3Y. Point K has coordinates -1, -1. K prime is at -5, -5. So that scale factor is 5, and there we can fill in the dilation rule. Looking for point T. T is at -4, 4. T prime is at -2, 2. New divided by original is going to be 1/2, and there is the explanation for the dilation from T to T prime. Number 3, triangle R prime, B prime, K prime is the result of dilating triangle RBK using the origin as the center of dilation. So this is going to be a reduction because it got smaller. Just be careful of the scale because the x-axis is going by halves. Just take note of that. All right, coordinates, because we're going to find our scale factor and the rule for the dilations. And it should be the same for every single one because we are not doing points separately like the other problem. We're doing an entire triangle. So B is at the point 6, 9. B prime is at 2, 3. New divided by original is going to be 1/3. Should be the same for all these. K is at 4 1/2, 3. K prime is at 1.5, 1. So it looks like we still have a scale factor of 1/3, which we should. R is at 9, 6, and R prime's at 3, 2. So yes, our scale factor is 1/3, and that would be the rule for the dilation. Any point x, y is going to go to 1/3 x and 1/3 y. Show the dilation on the coordinate plane by drawing dashed lines from M through the corresponding points. So through the B's and through the K's and through the R's and through the R's is about the same. Triangle B prime, K prime, R prime is a result of a dilation of triangle BKR centered at point M using a scale factor of 1/3. Problem 4. So we have triangle T prime, W prime, K prime. It's the result of dilating triangle TWK using the point P, which is the origin, as a center of dilation. Show the dilation on the coordinate plane by drawing dashed lines. So through the K's and through the origin, through the T's and through the W's, and it does show that the center of dilation is P. There we go. Calculate for the scale factor. So we can look at any pair of corresponding points, and we can look at their x's or their y's, and we have to do the new divided by the old. So if we take the T's, the original T is -3, -6, but T prime is -2, -4. So if you do the new divided by the original, you're going to get 2/3. It's between 0 and 1 because it was a shrink. Triangle K prime, T prime, W prime is a result of a dilation of triangle KTW centered at point P using a scale factor of 2/3. Number 5, let's look at this. Triangle T prime, M prime, H prime is a result of dilating triangle TMH using the point G, which is the origin, as a center of dilation. Okay, draw our dashed lines through the center of dilation and the corresponding points. There we go. Calculate the scale factor. So you can use any pair of corresponding points, and either their x's or their y's, it doesn't matter. I use the m's. So M was at 15, -5. M prime was at 12, -4. And the ratio, new to old, -4 over -5, or 4/5. And this is a reduction again. Triangle T prime, M prime, H prime is a result of a dilation of triangle TMH centered at point G, scale factor 4/5. Number 6, look at the scales. Both the x and the y-axis this time are going by halves. Describe the transformation. Okay, so we're doing a few transformations, and we're starting with triangle LFNC. And we are translating to triangle L prime, F prime, N prime, C prime. So we have one on the far left, and it's going to the far right. Orientation is not changing. That is a translation. And we've got to count to see how far things go. So you can do it from any pair of points, and N's kind of out of the way. So if we count over from N to N prime, remember every 2 boxes is 1. So 1, 2, 3, 4 to the right, so that'd be x plus 4, and 1, 2, 3 up, y plus 3. So that describes the translation. So now we're at L prime, F prime, N prime, C prime, and we're going to the double primes. So if we look at those, that is a reflection over the y-axis. The y's stay the same, but the x's change signs, and that's on our reference sheet from Unit 3, which can be helpful for this unit. You might want to locate that. Now we're going from the double primes to the triple primes, and it got smaller, so it is a dilation. And we can look at any pair of x's or y's, new over the original, to figure out your scale factor, and that is 1/2. Easiest ones would be to look at the points on the y-axis, the c's, because the new is at 1/2 and the old is at 3, and 1/2 is half of 3. Similarity is having exactly the same shape, but not necessarily the same size. Two figures are similar if and only if, remember that's a biconditional statement, goes in both directions. One figure can be obtained from the other by dilation or a sequence of transformations that includes a dilation. We have a word bank there and we have to fill in the blanks. Let's see what's there. When a sequence of transformations includes something, the resulting image of the sequence of transformations is something to the preimage. All the angles of the resulting image, oh, we know this one for sure. All the angles are going to be congruent to the corresponding angles of the preimage. The corresponding sides of the image and preimage are proportional. Let's go back. When a sequence of transformations includes, a dilation is going to do this change, and it results in an image of the sequence of transformations is similar to the preimage.